Alright, hello guys. So today we're going to continue solving logarithmic equations, but this time there will not be a log on each side to cancel out. So we're not using the one-to-one property. We're going to use a different technique. So number 2 starts pretty easy. As we proceed through the even ones, it steps up as far as being more and more difficult. So follow along, and then you're going to do the odds for your assignment. Okay, so the idea is we want to be able to cancel out this logarithm to isolate p. Just like all equations, you want to isolate the variable. Well, if you remember, we first learned about logarithms solving exponential equations. So if I had an exponential equation, let me come up here where there's some room, say like I had 5 to the x equals 9. Then to cancel out a base, I need to take a log base 5 of both sides, and that's what cancels out a base. So if a logarithm cancels out a base, it only stands to reason that a base cancels out a logarithm. To cancel out this logarithm, I need to drop a base 12 down here, and that cancels out and isolates p. And of course, what you do to one side of the equation, you do to the other side. Now, this notation might be a little confusing at first. I'm going to write a little 12 down here, and the way you need to read this is that it's 12 to the second power. And 12 to the second power, you should know, but 144. So we drop a base 12 on both sides. The base cancels out the logarithm, which isolates the variable. The other side, you also drop a base, and you get your answer. Now, it's real common for people to kind of screw this up a little bit when they first learn it, and look at something like this and then go to the calculator or in their heads and just do, 12 times 2. But it's not 12 times 2, it's 12 to the second power. Okay, let's look at number 4. Well, this one, we have a 8 multiplied by the logarithm, so the first thing I need to do is divide that 8 on both sides to cancel that out. So I have log base 6 of k equals negative 8 divided by 8 is negative 1. So now we're at the point where we want to cancel out the logarithm. Again, a base cancels a log just like a log cancels a base. So you drop a base 6 down here. The reason you use a 6 is because there's a 6 there. And you drop a base 6 down here. That cancels out. You get k equals 6 to the negative first power. Now, if you use a calculator for 6 raised to the negative 1 power, you get that. Don't forget there's this fraction button there, which tells you that it's 1/6. Ideally, you just remember one of the rules that we went over a while back. Anything raised to a negative power equals 1 over that thing to the power. So that was the negative power rule. But if you need to use a calculator, you need to use a calculator, whatever. But anyway, that's the answer. And you know what I should do, just for the sake of integrity, I'm going to check the answers, 144 and 1/6. Let me scroll way down, 144, 1/6. And let's preview number 6. Negative 74 over 25 is what we're shooting for when we do this one. So let's see how that's done. Okay, so there's this minus 4, and it's outside of those parentheses there, so we can cancel that out by adding 4, and then add 4 to this side. That cancels out. Log base 5 of b plus 3. Hold on. Oh, geez, I'm sorry. Just like when I'm teaching in class, just got to throw a sneeze in there every so often. I hope that wasn't right into the microphone. I tried to cover it up and turn my head. Sorry. Okay. Back to the problem. So I added 4 to cancel this out. Add 4 to the other side. Negative 6 plus 4 is negative 2. Now you might look at that plus 3 right here and say, well, I guess it's time to minus 3 to cancel that out. That's not exactly right. You can't really access anything in those parentheses until the logarithm is gone. It's sort of an order of operations thing. That log sort of has these this right here tied up. You just can't get to it. So to cancel out that log, you drop a base 5, and then you drop a base 5 here. That cancels out. B plus 3 equals. You can do 5 to the negative 2 on a calculator, or like I explained up above, the negative exponent rule makes it 1 over 5 squared. And then hopefully you know that 1 over 5 squared is 1 over 25. But just in case I need to, I'll illustrate that on the calculator. So we had, going back up to this step, we had 5 raised to the negative 2 power, and then you hit the fraction button, 1 over 25. At this point, now we can isolate b. We definitely can subtract 3. And 1 over 25 minus 3, well, I can just take what's on the calculator right now and go minus 3. And there it is, negative 74 over 25. If it wasn't already in the calculator, 1 divided by 25, oops. Just go back in time a little bit. So you had 1 divided by 25 minus 3, and then hit the fraction button. And there it is, negative 74 over 25. And that's what we saw when we sort of previewed the answer. Number 8. So the steps to solve this. I need to cancel this 2 by subtracting it, just like you would in any other sort of equation. That's going to be 18. This negative 9 is multiplied by log. Now you might look at the negative and say, oh, minus 9, I need to add 9. Nope, it's times. You have to do the opposite of the operation there and divide by negative 9. To cancel that out, divide this by negative 9. 18 divided by negative 9 is negative 2. To cancel out a log, you drop a base, and the base you drop is determined by the base of the logarithm, and this logarithm doesn't have a base. Well, it does, it just doesn't have one written down. You're supposed to know if there's not a base written down, it's sort of a default. What is the base? Go ahead and think about it. Okay, if you said that's base 10, you're right. Remember, that's called the common log. When there's no base, you assume it's base 10, so you drop a 10. That cancels out. M minus 10 equals 10 to the negative 2. That's 1 over 10 squared. And I hope you know 10 squared is 100. So now we need to add 10 to both sides. 10 plus 1 over 100 is 10 and 1/100th. But I'm guessing that the answer key is actually probably going to have it as an improper fraction. That's kind of how this software works. So let me hit the fraction button. So that's 101. Oh, what did I do wrong? Something's not correct. Oh. Yeah, that's 1010 over 100, and then it reduces, and you get 101 over 10. Sorry, I thought I had it wrong for a minute. I was doing it like in my head, and then looked at the calculator, and the answers were different, and then I realized when I did it in my head that there's this whole other step involved. So anyway, yeah, if I struggled through that one, I'm sorry. Let me just recap a little bit. Minus 2, both sides because of that positive 2. Divide by negative 9 both sides because it was times. The base you drop is 10 because that was a base 10 logarithm, the common log. 10 to the negative 2 is 1 over 10 squared, which turns into 1 over 100. Add 10 to both sides. You get this answer. If I do that in the calculator, I get 101 over 10. Let me scroll down to number 8. Whoa, that's a whole different answer. What the heck? Oh, I typed it into the calculator wrong, for crying out loud. I typed 10 plus 1 over 10. It's supposed to be 10 plus 1 over 100. Oh my gosh. Well, I could just stop recording and go back and redo all this, but then it'd be kind of like lying. I think it's fair for you to see that I made a mistake. So 10 and 1/100th. And then do it on the calculator. It's 1001 over 10. So, oh, my struggles. I'm sure you care a whole lot, right? Okay. Just laugh at me. Just do that. Tell you what, when you get to the assignment on Google Classroom in the comment section, just type in ha 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 so I know that you laughed at me for screwing up. Number 10. Okay, so the whole point is to cancel this, to isolate the v. We got stuff in parentheses to deal with, but we can't deal with that until we cancel out the logarithm. But you cannot cancel out the logarithm until this and this are gone. So we're going to start this by adding 6 to both sides of the equal sign. Negative 5 log base 12 2v minus 6 equals negative 10. Since that's times negative 5, I'm going to divide by negative 5. That cancels out. Negative 10 divided by negative 5 is 2. To cancel out log base 12, I need to drop a base 12 and drop a base 12 over there. 2v minus 6 equals 12 squared. Well, we just did 12 squared on the first problem. That's 144. Now I can add 6 to both sides. 2v equals 150. Divide by 2, v equals 75. Oh, please, please, please let me not have made a mistake. Number 10, 75. Okay. So I hope you're able to follow through all those steps. It would be like if this were never here and that was just negative 5x minus 6 equals negative 16, your first two steps would be add 6 to this side, divide by 5. So that's pretty consistent. After you do that and you get to the logarithm, you drop the base, and then what you get is like another algebra problem to solve. So kind of look at it that way. Now these last two problems have ln, and the directions say round to the nearest 10,000th. So how do decimals work? There's the decimal, tenths, hundredths, thousandths, 10,000ths. So 4 decimal places is what we need to do the answer. Why is this one different? Well, think about the base of the natural logarithm. Well, I do the first step. I'm going to minus 2 on both sides. ln x minus 1 equals negative 1. Okay, remember, what's the base of the natural logarithm? It's e. So I have to drop a base e to cancel out ln, but then I have to drop a base e over there. I get x minus 1 equals, now in the previous problem, 12 squared, that's 144. That's pretty easy. What's e to the negative 1? Well, that is going to take a calculator. E raised to the negative 1, 0.3679 to the 4th decimal place. It's an 8, but the next digit's a 7, so it rounds up to 9. Now we need to add 1 to both sides. X equals 1.3679. So yeah, ln's use base e. Base e, you have to use your calculator. It's an irrational number, which means it's all the decimals and everything. So this last problem that you're going to do for homework, you're going to get a decimal answer. You're going to use the calculator, and it'll work out a lot like number 12. Let me check. Yeah, there it is, 1.3679. Got it. Okay, I hope this makes sense to you. I realize I struggled a little bit. Just stupid. The whole new math you're learning today is when you've got a logarithm in an equation and you want to cancel it out, you just drop a base, whatever the base is of the original logarithm. It makes them cancel out. Do that to the other side. In the easier problems, that's just your answer. In the harder problems, you might have a few more steps after that. But that's the whole fundamental idea behind this. Okay, I'm going to stop here. Otherwise, I'll just go on needlessly. So good luck on this. As always, email me or use the comment section if you have questions.